Well, sir.
Okay. Thank you. So, today's a gate session. So, I will handle the torsion of circular shafts topic in strength of material subject. It is more important in gate syllabus also. So, we have quite few number of questions asked in a couple of years. The last series also we have questions in the torsion of circular shaft. So it is a very important factor. So torsion and circular shaft. So in this session, we're going to look upon sort of the objectives of why we are discussing torsion and what are the needs and how to calculate and we need to calculate the power transmitted by the shaft. And since we are using a solid shaft and a hollow shaft, so these are the things we need to understand. At the end of the session, we came to understand about these concepts. And also we need to include some assumptions once we start go with torsion. So in many of the industries and factories, turning forces is always applied to transmit energy by means of rotation. Once we start the machines and whatever it is, but once we supply the power, the shaft here is start to run. So turning force is always started here. So by means of this, that energy will be transmitted from one end to the another part. So the turning force is a major thing which is applied either by shaft or pulleys or in some applications like rims. We need to incorporate some distance from the axis of the shaft or pulley or whatever it is. So the main objective of this is the product of turning force and the distance between the point of application of the force and as well as the axis of the shaft. So that term is called as torque. So it is calculated between the point of application of the force and the axis of the shaft along with the distance. So this term is called as torsion, and we might refer this torsion as turning moment or twisting moment. When the shaft or pulley or a keyed or rim are subjected to torsion, we need to discuss about every cross section. Either it may comes under stress or strain or majorly shear stresses. So these are the major factors that incorporate in torsion. So we're going to discuss elaborately about this torsion in this session. So these are the major things that we need to consider for torsion, shafts and springs. So we only focus on torsion here. Um, so along with this, I will give you a glimpse about torsion stresses and stresses in springs, and then we'll move on to some torsion problems. So torsion gate problems, solid gate problems, and we will discuss about how this problem, how we understand the torsion problem, and how we're going to work out it, and we will get the answer for, or we will get the solution for the given questions in gate syllabus. So since the gate questions, we all we might know about the gate questions, so it will not come directly, so we don't know the exact meaning. Once we read literally, we need to read again and again, then only we came to understand what they have given, the data they have given. So that's a major reason the gate by scoring more marks in gates are very pretty tough and difficult. This is a major reason why, because we might not understand the question properly. If we understand the question properly and what are the data which is given properly, then it is easy for everyone to score more marks. Okay. So this is a torsion. This right side picture will give you some look about our animation about the torsion of the shaft. The shaft is fixed at one end, and we will try to give some force or rotate or twist on the other side. There will be a movement, a twisting movement to happen. So look at this animation on the right side. So the torsion, which refers the loading of a member that tends to cause it to rotate or twist. So such kind of loads are called torsion. In other words, we may call it as rotational moment or twisting moment, or sometimes it may be a couple. So when the torque is applied to a member, the forces, what are the major forces developed inside the shaft is shear stress. Why it happens? So once, if it is an ideal shaft, once we try to apply load over the shaft, there will be a formation of stress and strain. See here, look at this right picture. So here, the load is acted in a rotated basis. So the stress will be developed within the member, but here the twisting of shaft is happen. So here the stress and strain. Apart from this, there will be another guy which is called shear stress. Why? Because we disturb the nature of the shaft. We try to twist the we try to twist by applying the load. It, it deviates from its actual position. So it turns to some angle. That's it. That's why they mentioned that resulting in angle of twist of one end of the member relative to the other. That's a major reason. So why we call this as a torque. Somewhat, sometimes it may be called as twisting moment or couple. Initially, it is an actual position. We try to give some loads. With the help of that, it deviates its angle, deviates its nature. It twisted. So here we might focus on the angle of twist at the one end of the member which is related to the other. See, at this left side it is fixed, it's completely fixed, and at the right side it is twisted. So this is the actual definition for the torsion. Okay, so I hope you might understand this concept of torsion. So it's simply whenever a force is applied or a torque is applied over the member, shear stress is developed within the member and a torsional deformation is created, which results in angle of twist or angle of twist of one end of the member which is related to the other. So look at the left side picture. At the picture A, it depicts the two finger holds the a shaft, and the second picture which depicts the angle of twist. See, the alignment changes. Look at this picture. So here. So compare these two pictures A and B, which gives the twisting motion of the shaft. So these two pictures will give you a glimpse or a better idea about the torsion. Shall we move to the next? Okay. So the next one is, so the general equation for torsion equations. So in your lower classes, you might study about the torsion problems, and whenever we go for a problem, whenever we go for a topic, we first understand how this expression is generated. So generally, this mechanical equations have a great background in physics as well as the mathematics. We need to know about the calculus. We need to know about the calculus plays a major role by creating expressions to solve many of the applications in mechanical engineering, not only in mechanical engineering, in different fields also. So, for finding the solution for any problem, we need some expression. Am I right? Without any expression, without any formula, how do we apply the load? How do we apply? How do we calculate the force which is acted over the component? So that's a major thing. So we need to create an expression. then only the complication of the problem will be simplified. See, for example, so this is the expression for torsion. So T, which notates torsion, torque or twisting moment, which is mentioned the unit of Newton meter, and J as a polar moment of inertia or polar second moment of inertia for the shaft axis, and unit is M power 4, and tau is a shear stress at outer fiber, and its unit is Pascal, and the next one is the radius of the shaft, will denote in meter or inches, and GRC might be mentioned as modulus of rigidity or shear modulus. We also mention this as Pascal. The unit is Pascal, and theta is the angle of twist, which is in radian, and L will be the length of the shaft. L will be the length of the shaft. So look at this expression. If you know the torque or twisting moment value, it is easy for everyone to calculate the missing details like polar moment of inertia or tau or radius or modulus of rigidity or angle of twist or length. See here, if you want to know the diameter of the shaft, then there will be a formula for J, the polar moment of inertia. So it is easy for us to calculate the J value. And also we know the formula for torque and twisting moment and polar moment of inertia. With the help of these three values, we can easily calculate the remaining values. So these having expressions for T, J, and tau, these three have expressions. G is constant, right? Modulus of rigidity, we have some constant value, and radius of the shaft. The problem itself, they have given the radius of the shaft, and the angle of twist. This probability is given, or we need to calculate the angle of twist, and the length of the shaft is also given. So without this, how can we calculate the torsion of the shaft? So you try to understand the expression. You may not be solve an expression literally. We need to work for it. Then we will get the expression for this torsion equation. See in the previous slide, you just look at this. This is the angle of twist, right? Right. This is the angle of twist. So this red dotted line indicates the actual line, and this part will give you a glimpse or will be the solution of the twisted angle, right? Twisted angle. So here, if we want to calculate the expression for this, T by J and tau by R is a final expression. Initially, by creating an angle in the shaft, in the animation they shows that it will twisted. So by you just literally just assume there will be an angle called A, and at the center it's O, and the angle of twist is A naught or A dash. So we need to calculate the shear strain. So shear strain is nothing but the deformation per unit length. So here the deformation is A dash. So the twisted along with the length, which is otherwise called as which is equal to the tan theta, where it might be, we just imagine this as deformation per unit length. And the arc A dash is otherwise we may notate it as R into theta, where R is the radius of the circular shaft and the theta is the angle of twist, which is in radians. So if you have the angle pi in degree, we get the outermost layer of the shaft, modulus of rigidity. So pi equal to tau by c. So with the help of the above expressions, we might get tau by c equal to g theta by L. Similarly, for tau by j equal to tau, t by j equal to tau by r. This way, the torsional stresses and strains are explained. So it consists of different equations. For t, there will be expression called pi by 16 into tau into d cube, and also for we also know the expression for j, polar moment of inertia also, and the power transmitted. The formula for power transmitted is also already we know that 2 by nt by 60. So these are the known and the default values. So with the help of that, we can able to solve for different problems, and the expression for j equal to pi by 32 into d power 4. So since we have two models of shaft like solid shaft and the hollow shaft. For solid shaft, it is pi by 32 into d power 4 polar moment of inertia, and for hollow circular shaft, it is j equal to pi by 32 into capital D power 4 minus small d power 4. Inner dia and external dia. So these are the major equations to solve whatever the problems in torsion equation. So for that, we know the expressions. Okay, so expression plays a major role. Without knowing the concepts of expression, we might not solve any problems, because once we go for a gate, we need to prepare ourselves for a gate mentality. So they might ask the questions from each and every point of the content, the contest. So we need to look a brief, sorry, we need to look a deep discussion about this torsion equation, not only torsion equation, but every concept also. Okay? And for solving this kind of torsion equation, we have some assumptions. So not only for torsion equation, in our curriculum, mechanical engineering or automobile engineering or mechatronics, so we need to get a solution. We need to find a solution. We need to assume might be the material properties and some specifications and restrictions. Why these assumptions are? Because the assumptions are made here to find different values. So we just try to assume the shaft is straight and the load applied over the shaft is uniform. Then only we can easily calculate the solution. With the help of the solution, we might change alternately if the shaft has some deflections or some irregular cross sections. So we can with the help of the reference, we take the assumption as a reference, and we solve the different peculiar problems to find the solutions. And these are the major assumptions which will be followed by using these torsions. What are all? Material of the shaft is homogeneous throughout the length of the shaft. Which in simple term we may call it as the material of the shaft is uniform throughout. Material of the shaft is uniform throughout the length of the shaft. Why it is? Because in olden days, the shafts are used in many applications. So they don't want to waste the time. They simply apply the load at any one of the end. They calculate the stress, strain, and the deformations. They have assumed that if we try to apply the load over any point, it will evenly sweep over all the or entire length of the shaft. That's why they assumed that it will be homogeneous throughout the length of the shaft. And also for the torsion problem, the shaft should be in straight, and the cross section of the shaft is uniform throughout its length, which means shaft has a regular cross section, and also it is in a straight, and it is a homogeneous. It is a pure shaft without any deflections or any deviations. So apply a load, the shaft will twist, will try to twist, and the shear stress will be developed, and we're going to calculate the angle of twist or torque at twisting moment, or torque, or the shear stress, or anything. And the third point is an important point. The torque is constant along the length of the shaft. This is a question that many of the students may ask. Why we consider the traction is constant along the length of the shaft? So the answer is at the first 2 points. Since we are considering the material of the shaft is homogeneous throughout the length, and also the shaft is straight and uniform cross section. Once we apply load over the component at any point, it will act accordingly throughout the length of the shaft. That's why torsion is constant along the length of the shaft, or throughout the length the torsion value is similar. And the fourth one is cross section of the shaft. The plane before torsion remains plane after torsion. So you just recall the first slice or second slide, the right side, the picture, the animation, the straight shaft. Once we apply load, it will twist. The red line, dotted line indicates it is plane. It looks in a straight line. After the twisting moment, it also similar position. So I will recall that point again. And the fifth point is radial line remains radial during the torsion. So the fourth and fifth are almost similar. Radial lines remains radial during the torsion. And the next one is stress included during torsion or within the elastic. So this is another important one. So stress included during the torsion or within the elastic limit. Why we are, so you just look at this word elastic limit. So why we are intent about elastic limit? So anyone explain so what's the actual meaning for this stress induced during torsion or within the elastic limit? So why it should be in elastic limit? Can I get the interaction from anyone? Anyone can explain? Is there any reason behind this? Why we are considering the stress which is induced during torsion within the elastic limit? Can anyone respond? Okay. So since we are following the above 5 points, look at the 5 points. So it is homogeneous, it has uniform cross section, and the torsion is same throughout the length of the shaft. For this, the cross section should be plane before and after. Radial line remains radial during the torsion. So, if it not follow the sixth point, it should not be within the elastic limit, which means it not follow the sixth rule. And once we apply a load, the stress induced during the torsion, now it is in the plastic stage. What will happen? What will happen? We cannot regain the original shape of the shaft, right? Then how do we calculate the torsion value? That's a major reason. We assume that the stress induced here during the torsion process, it should be within the elastic limit. So once we remove the load, it regains its original shape. That's a major reason. These are the major assumptions we should be following. By using this assumptions, and also we take this as an reference, we solve the problems. So let me go back to the second slide. See, look at here. Here, see this, the red dotted lines, which would be a plane. After twisting, it's similar, it remains the same plane. It may not be deviated. That's the point which indicates here. Fourth point, cross section of the shaft with a plane before torsion remains plane after torsion. Okay, and just try to look at this video regarding torsion.
எதெல்லாம் போட்டு சசி ஆக்சுவலி சார் இந்த இவங்க ஜேசன் கூப்பிட்டாரு சரி நம்ம பாடம் எல்லாம் ஓகே ஒரு மாதிரி நிக்கணும் Oke, Maria. அதுக்கு தான் பிளான் பண்ணி கூப்பிடுறது கண்டிப்பா பவுன்ஸ் போட்டால வாங்கி வந்து மகாராஜா அதுக்கு தான் பிளான் பண்ணி கூப்பிடுறது சிஸ்டர் டேய் நோட் கண்டிப்பா இருக்கும் எனக்கு வந்து ஓபனிங் கொடுக்கலனா பரவாயில்லை ऐसे टीम कैप्टन प्रेजेंट टीम कैप्टन वाइस कैप्टन कितना एक जीवन दिया था कार्तिक ఎందుకు పాటడా రిసెంటింగ్ కూడా వెయిటింగ్ ఉంది అది சொன்னானே பாட்டை நீ மறந்துட்டா அவன் பையனுக்கு இன்னும் பாடுறேன் பாட்டு போடாமல் டிவி ஏரியா நீ பாட்டு போட்டு அவுட் ஆகிட்டா அதுக்கடுத்து பார்க்கலாம்.
So the video will give you a glimpse about the torsion equation. So this is what I have mentioned in the previous slide. So the angle of twist which will be formed once we start applying a load over it. So I have mentioned is A0 A naught, but here in this video they mentioned as B dash. So with the help of that, we're going to calculate the angle of twist, right?
See, English 4 o'clock.
So this is the important things that we need to understand about the ductile material. In ductile material, once we start testing, the maximum shear stress will occur. But in brittle material, the shear stress will happen only by means of the maximum tension. This is also the important factor that you need to understand, right? So in that video, they have mentioned about the another important thing, which I will explain this regarding solid shaft as well as hollow shaft. See, look at this. So this is the shear stress which is increased from here to here. Okay. So this is in solid shaft. Solid shaft. If it is for a hollow shaft, the shear stress is increased from here to here. This is a major reason why in many of the automobile applications, the hollow shaft is preferably preferred or used instead of the solid shafts. This is the major reason why the hollow shafts are used continuously than the solid shafts. So in this, you might understand that the strength of the shaft, which one is more strengthened? The hollow shaft is strengthened than the solid shaft. Okay. These are the two important factors that I want to discuss at the end of this video. So for hollow shafts also, we have the similar expressions. Instead of using a single diameter, we will go for inner dia as well as outer dia. Hold on a minute. Okay. So these are the difference between the solid shaft and circular shaft. Hollow shaft as well as a solid circular shaft as well as hollow circular shaft. So the major things what we have discussed is the expression for torsional and the difference between the solid shaft as well as hollow shaft and the polar moment of inertia, how it twisted and how we are going to calculate. These are the things that we have discussed. So in this video also we came to discuss stepped shaft. So how we going to calculate the torsion equation for the stepped shafts? Okay.
அண்ணா
எஃப்எம் அமுக்கு
அண்ணா
லேபுக்கு 50ஆ
இல்லைண்ணா அது டோட்டல் 50 மாற்றி அனுப்பணும். நான் மாற்றி அனுப்புறேன்.
அனுப்பிச்சுக்கோ.
அது காஸ்கோல இருந்து எடுத்து அனுப்பணும்.
ஹாஸ்பிட்டலுக்கு
ஆமா, அந்த மாதிரி காஸ்கோ இருக்குது. அது எடுத்து இதுல போய் ஆட் பண்ணி அப்புறம் தான் அனுப்பணும். இதுல மீட்டிங்ல போகணும்.
நாலு மணிக்கு தான் இருக்கீங்க.
அவங்களுக்கு மீட்டிங். இப்ப நான் அது என்னோட கிளாஸ்ல கன்சல்ட் பண்ணிட்டு இருக்கேன்ல. ஆனா என் கிளாஸ்ல கன்சல்ட் பண்ணிட்டு இருக்கேன்.
அப்புறம் இது கூட இருக்கணும்.
முடிஞ்சது என்னோட கொஞ்சம் அதிலிருந்து எடுத்து தரேன். காஸ்கோ சொல்லுங்க.
அப்படியே வரலையா? ஓ அப்படியா? கேக்குது இல்லையா? So I don't know about this. You didn't hear the video. You didn't hear the audio, right? Is it audible? Okay. So I will explain this. See here, a stepped shaft is used here. So different torsions are applied here. So we start with a free body diagram and how the load is applied here. Then we'll look into one by one. So this is a reference axis. See here, the torque diagram which is shown for this member. The torque diagram indicates that the torque value graphically for different portions of the shaft. The maximum value of the torque is in CD position of the shaft. Okay, but first let us study about what is a shaft. So we need to discuss about what is shaft. So So first we need to discuss about what is meant by shaft before entering into the torsion concept. So where we going to apply load? We are going to apply load on the shaft or pulley or rims or any key doors. So in this aspect, first we look about what is meant by shaft. So shaft is nothing but it's a one of the machine element which is used to transmit power from one machine to another machine or one guy to the another one to transmit the power. Okay. And the next one is so please hold on a minute. So there is a problem. So the shafts may be of a solid shaft or a hollow shaft or tapered one. So in the previous video, I have explained you about what is solid shaft as well as hollow shaft. So which one is better? The strength will be probably is hollow shaft, which has the better performance than the solid shafts. Okay. So these are the different shapes of the different sections of hollow, solids, and tapered. So now, what is torsion? So this will be considered a shaft, and the so simply we may call it as the tension or the turning force of the or the cross section, the turning force on the shaft. Okay. In simply in simple manner, we may express this as the torsion is experienced whenever we apply a load or whenever we apply a force on a rod, which accepts that force and it try to tense or twist or turn the rod according to the force what we going to given. Okay. So that is called a torsion. So the term is mentioned as torsion. The force applied can be converted into torque, which means F into D. So F is the applied force and D is the diameter of the shaft. So this is the formula to find the torque. T equal to F into D. Right? And so now you just take isolating shaft. So here in this picture, there is no resisting forces. It's simply rotating. There is no resisting force is acting. So here no torsion or no twisting because there is no resisting force. So no torsion, that is equal to no twisting. One end of the shaft is fixed or it is resisted. Now the other end try to twist or tends to move, then there will be a formation of twist. In this case, the torsion will come into act. Comparing these two things, it continuously starts rotating, but here it is fixed. But here, the twisting movement will be happen when it is fixed. So that is the major difference between the both two things. So what are the effects of torsion? The torsion creates distortion and the stress on the shaft, and it leads to its eventual rupture. And also it causes loss of energy. Why? Because the first picture, the shaft starts rotating without any disturbance, any distraction. But there is no torsion or no twisting movement. But once it starts arrested by one end of the shaft and the other end tend to move, there will be a formation of twist. So what automatically happens, there will be a distortion. So automatically the shear stress will be eventually formed, and also at some time the rupture may happens, and also it causes the loss of energy, major loss of energy also happen here. And now the students who are studying torsion to prevent distortion in the shaft and also energy loss. How? And also thereby improving efficiency of the mechanical system. So how can we reduce the energy loss and the distortion, and how could we improve the efficiency of the mechanical system? So that's a major thing we need to discuss. So these are the major effects of torsion once we start discuss about the torsion problems. Okay, so let us see some everyday examples about torsion. Okay, um, so initially the torsion can takes place in car engine. So look at this car engine. So here the piston start rotating, start accelerating from up and down, and the crankshaft is also rotating. The crank along with the piston starts rotating. The shaft is clubbed with the crank. So here the torsion will happens. So look at this animation. And the second one is lathe machine. So the another example of the lathe machine, the workpiece holder. And the third one is motor pump. So here also the torsion will comes into the picture, and the major parameters that we're going to discuss are involved in this is torque and the diameter of the shaft and the angle of twist. Once we apply a torque, there will be a change in the plane angle. That's the angle of twist. So look at this. Yeah. So now the three are the major parameters. One is torque, the T is applied, and along with the diameter of the shaft D. So the next one is angle of twist. How it will happen? So once we apply a torque, once we apply a force over it, so what would happen? It tends to rotate. It try to rotate, but the one end of the shaft is fixed. The another end is try to move. So there will be a deviation or a distortion of the shaft that takes place. So let us consider that M is the initial point, and so once we start applying a load, it try to deviates or distortion happens. The new point will be M dash. So the angle between these two is angle of twist. So this point will indicate the difference between. So this is the angle theta which takes is called angle of twist. And what is the displacement? See here, the displacement is nothing but, so initially it is the M will be placed here. So once we start applying the torsional load, it will try to deviate or it will try to move the position of the point, but the one end of the shaft is fixed. The another end is tends to move. So there will be distortion happen. So here the point M is moved to the another segment called M dash. So this is called displacement. And the major purpose of this and the major thing is
Karthik, 25 mark தானா உங்களுக்கு?
25 அனுப்பியிருக்கேன், 50 அனுப்பியிருக்கேன்.
நான் 25 போட்டு அதான் கேட்குறேன். டெவலப் பண்ணி
மெயில் செக் மெயில் உங்க மெயில் செக். Okay, so displacement. So I already explained that what is meant by displacement. That's a shift between point M to M dash is displacement. And the next one is what it will impact by means of this displacement M and M dash. So this is help to calculate the shear strain which is included in the twisting of the shaft. So there is a two factors, one is shear strain and shear stress. These are the two factors that we need to understand. So here The displacement of M and M dash is used to measure shear strain. Okay. See, look at this motor pump. The shaft starts rotating from the left to right. So here, the shaft will not be homogeneous, but the shaft could not have the similar cross section. It's similar. It's pretty look like a stepped shaft, right? Just look at this animation. The power is transmitted. The motor is transmitting the power to the pump, right? So here the power transmit is P, is the measure of the energy transmitted to the other end of the shaft. So, so we might calculate this power by means of general term P equal to 2 pi nt by 60. So here R, so we might use this R as 2 pi nt by 60, right? 2 pi. So here the word pi is used here. So and the unit of this power equal to watt. Okay, so we already know about T is the torque and N is the number of revolutions per minute. So energy is transmitted from here to here, so the motor to the pump, right? So this is the pump, and here the power is transmitted from the motor to the pump. So how do we calculate the power? With the help of this equation 2 pi nt by 60, we're going to calculate the power of the power in watts. Okay. So these three are the general day-to-day applications of the torsions. Okay. So now we look at the torsional rigidity for two different materials. This is the material number 1 and the number 2. So material number 1 has a more torsional rigidity than the material number 2. So we might so we have mentioned that material 1 has more torsional rigidity than the material 2. So how do we calculate the torsional rigidity?
உங்களுக்கு அனுப்பிட்டுருக்கிறேன் கரெக்டாக மட்டும் கன்ஃபார்ம் பண்ணிட்டீங்கன்னா நான் யாராவது கணிச்சுட்டு அவங்க நாளைக்கு.
So mu for calculating the torsional rigidity, mu is the T by theta into M. What is meant by theta? It's torsion, the angle of twist and the length of the shaft. Okay. V is a torsional, torque, and the theta is the angle of twist, and the L is the length of the shaft. So this is for different materials. So what is meant by torsional resilience? So torsional resilience is nothing but it's an internal energy which is stored in the shaft during the torsion, and it allows it to come back to its original shape. So you see here in other words, so you just look at or you just recall the assumptions of the torsion equation. I hope it's a fifth point. Stress included, so stress induced in the shaft should be within the elastic limit. What it means? It means it should regain its original shape. So here the torsional resilience is also trying to induce the same point, the internal energy stored in the shaft during the torsion, allow it to come back to its original position. So it will regain its original position. So that's a major word which indicates the torsional resilience. So for hollow shaft, the U equal to the torsional resilience, U equal to x square by 4e into d square plus small d square by d square, and along with the volume of the shaft. And for solid shaft, so here the capital D mentions outer diameter and the small d mentions inner diameter, right? For solid shaft is pretty similar. The equation should be U equal to x square by 4e into volume of the shaft. So these are the two equations for calculate the torsional resilience for hollow shaft as well as solid shaft. Let's try to know that the capital D indicates the outer diameter and a small d indicates the inner diameter. So along with this, the volume of the shaft, we're going to calculate the hollow shaft torsional resilience and the solid shaft resilience. Okay. And the next important thing is hollow shaft versus solid shaft. So you might have some knowledge regarding hollow shaft and solid shaft. So what is the major reasons why the hollow shafts are used, and where we going to apply the solid shafts in many of the applications? The hollow shaft, which contains the same amount of material at all the ends, if hard, and solid shaft is also same weight, whereas in solid shaft, the distribution of material is uniformly throughout the shaft leaves. Little material at the end. The difference between the both is resistance to bending, resistance to torsion. In the previous slides, we might understand the shear stress which is induced, which is majorly in solid shaft and minimally in hollow shafts. So let us have a deep look. What's the difference between this hollow shaft as well as the solid shaft? So in hollow shafts, the material at the center is removed and spread at large radius. Therefore, the hollow shafts are stronger than the solid shafts with the same weight. So look at this point clearly. This is the major reason why hollow shafts are widely used than the solid shafts. The center of the material is removed in the hollow shaft. That's the major point. The major point. And large radius of the shaft is removed. Therefore, the strength of the hollow shaft is comparatively higher than the solid shaft, the same weight. And the stiffness of the hollow shaft is more than the same weight solid shaft. In the first shaft, we assumed that solid shaft have same cross section and it is homogeneous. But we might not know about what the exact is. That's why hollow shaft is commonly used. And the strength of the hollow shaft is also more than the solid shaft. Along the same weight, when we compare the same weight, it is quite high than the solid shafts. And the natural frequency of the hollow shaft is also high. And comparatively, hollow shafts are more costlier than the solid shafts. Why? Because it has a features like stiffness, strength, and better natural frequency, and stronger. That's why the hollow shafts are widely used, and also the cost-wise it is also improved. Right? Because we need to remove the material, right? So it takes some machining process, right? So the cost-wise it is higher than the solid shafts, and the diameter of the hollow shaft is more than the solid shaft and require more space. Yes, it's quite typical one. The solid shafts occupy less space than the hollow shafts. And diameter of the hollow shafts, yes, it's more than the solid shaft. Hollow shafts have more polar moment of inertia, which enables them to transmit more torque than the solid shafts. So this point will give you an important note. The polar moment of inertia is more in hollow shafts. So it transmits more torque than the solid shafts. Okay. And hollow shafts do not transfer more power. They do not transfer more power. But power to weight ratio of hollow shaft is more as compared to the solid shafts. So for transferring more power, the solid shafts is quite higher, but power to weight ratio, but comparatively, which is better than the solid shafts. And the another important factor, hollow shaft is slightly lower than the solid shaft is when we are going to, or when it is subjected to bending or bending or bending force, like solid shafts are stronger than the hollow shafts only when it's subjected to bending. Other than that, we have plenty of positives in hollow shafts. So the hollow shafts are plays a major role in automotive industries, and it depends on the applications of the shaft. Hollow shafts and solid shafts are widely used. The hollow shafts better for structural applications because it can beat the same load as solid shaft or lesser weight, like roll cage of off-road vehicles. Since in our Baja vehicles or go-kart vehicles, we're going to design the roll cage with the hollow pipe only, not solid pipe. Because since it's a lightweight, so the solid shafts is comparatively more weight than the hollow shafts. So we preferably go for hollow shafts. But transmission of power, when we go for transmission of power, solid shafts are used. Where it is drive shaft or crankshaft. The crankshaft is coupled with the drive shaft. The solid shaft. In that application, solid shafts are used. For for the load bearing types of shafts, it is always better to choose hollow shaft because the stiffness and rigidity are slightly higher than the solid shaft, but it can resist slightly higher bending moments also. Shaft for transmission of torque like crank and drive and choosing a solid shaft is always better because it has a high torsional stiffness. So in these cases, solid shafts are comparatively higher than the hollow shafts. In that aspect, we will go for solid shafts. Next one is polar moment of inertia. So what is meant by polar moment of inertia? The polar moment of inertia is nothing but the ratio of is defined as the ratio of polar moment of inertia to the radius of the shaft. So what it is. And it is also called as a torsional section modulus. So ZP equal to IP by R, where inertia, moment of inertia to the radius of the shaft. Polar moment of inertia, I by radius of the shaft, is called as polar modulus. Okay. And for solid shaft, these are some of the formulas or expressions to calculate polar moment and polar modulus for solid shaft as well as hollow shafts. And for solid shaft, IP equal to pi by 32 into d power 4, and ZP equal to pi by 32 into d power 4 by d by 2. Finally, we will once we solve this, we will get polar modulus equal to pi by 16 into d cube. And for hollow shafts, polar modulus equal to pi by 32 into de power 4 minus di power 4 by r. Whereas pi by 32 de power 4 minus di power 4 by de power d bar by 2, whereas r equal to d by 2. By solving those values, we will get pi by 16 dE. It's in the bracket dE power 4 minus dE di power 4. Whereas dE is the external diameter and di is the internal diameter. And r is the radius of the shaft. And the torsions of springs is another important one. So before we have discussed about the torsion of shaft, so now we will go and look into deeply about torsion of springs. Oh, because a spring is also an elastic material. That whenever we apply a load, it accepts a load, and whenever we release the load, it regains its original shape, stores some energy. So different types of springs are used in day-to-day life as well as in industries. So what are the major things that will be focused on springs? So initially, first we need to understand what is meant by spring. A spring is nothing but it is a device which is used to absorb energy by taking very large change in it. Whenever we apply a load over it, whenever we apply a load, it taking a very large change in its form without permanent deformation. That's a major point we to note. Without permanent deformation, it takes very large change or very large load, and it releases when it required, or whenever we release the load. For example, so we just look at your spring in the clockwork is used to absorb energy in the clock wound. This absorbed energy is gradually released at the show, but continuous rate as the clock runs. The clock runs continuously. The another example is carriage springs or leaf springs in automobile, which absorb road shocks by continuously absorbing energy due to shock by their deformation and then dissipating the same by means of vibrating. In two-wheelers, the best example, springs and suspension system absorbs the deformation. So different types of springs are used. One is torsion spring and bending spring. So what is meant by torsion spring? In torsion spring, a torsion spring is the one which is subjected to a twisting moment, and the resilience is mainly due to torsion. So we all know about torsion resilience and also twisting. How it will happen? It is mainly due to torsion. The helical springs which are subjected to an axial pull fall under this category, torsion springs. The helical springs which are formed by means of wounding a wire around a cylindrical mandrel in the form of helix. So this is a torsion spring, and the another spring is bending spring. Bending spring is nothing but which is subjected to a bending load only, and the resilience is mainly due to bending. And the leaf or plate spring, which is also falls under this category. So here, in this torsion spring, the common types of torsion springs, which includes helical torsion spring, torsion bars, spherical wound torsion springs. We mainly focused on helical torsion springs. In general, the mechanical springs as an elastic member whose primary function is to deflect. Yes, I already mentioned that it absorbs a very large load, and it regains its original shape whenever the load is released, and whenever we apply a load, it deforms, and whenever we release the load, it regains its original shape. The main motive is to absorb shocks and vibrations. Vehicle suspension system is the best example, and the springs in clocks and toys, which stores energy, is another a good example. And the spring balance for measuring the force is also one of the best example for springs, mechanical springs. And to apply force and control motions like cam and follower. Cam and follower is another pretty good example in automotive sector. So these are the different types of springs. Springs, or in general, it is classified into four types. One is helical spring, and conical spring, and disc or bevel spring, and leaf spring or laminated spring. So helical springs are subjected to axial pull, which falls under this category. I already mentioned about helical springs, and conical springs, disc and leaf springs are also used widely. And the loads, torsion loads, which is applied over this springs then and there. Okay, so next we will go into the so we will look upon some problems regarding these torsions and as well springs. So these are the different types of springs. Just take a look at it. So I will move to the next concept of problem solving skills in the gate. So these are the topics that we need to understand. So with the help of this, we're going to discuss how to solve the problems or how to solve the gate problems. So one by one we will discuss. Okay, the major thing that we need to understand in spring is stiffness. So what is meant by stiffness? The load which is required to produce unit deflection in the spring is called spring stiffness or stiffness of a spring. It's the major and the important term in the springs, stiffness of a spring. And we all know about two types of springs, bending and torsion springs. And farmer springs, mostly it's a leaf spring or helical spring. So they're the major types we have used. So these are the different types of springs that is available in day-to-day life and in many of the applications. So up to this, anybody have a doubt? So I will try to explain any doubts. So these are the formulas to solve the torque T equal to W by 2 and the torsional shear stress tau equal to TR by J, which means so this is these expressions only for springs. So W into D by 2 into D by 2, which means 8W D by pi by dq, pi into dq. And the next one is a spring stiffness W by del, which means deflection. So load by deflection is otherwise called as GD bar 4 by 8 D cube N. Finally, we will get GD by 8 C cube N. And angular deflection theta equal to TL by JG, whereas W, we're replacing the term W into D by 2 into pi dn by pi by 32 D power 4 into G. Finally, we will get the value of 16 W D square N by GD power 4. And the length of the wire L equal to length of one coil into number of coils. So length of one coil, so it's a circumference pi into D. And the N indicates the number of coils we have. So finally, we have pi dn for length of the wire. So let me look at the problem. This is one of the problem which is asked in GATE, I think for 2004 or 2005. Look at this problem. A circular rod of diameter D and length 3D is subjected to compressive force F, acting at the top point as shown below. Calculate the stress at the bottommost support point A. So a circular rod of diameter D and length 3D is given. So diameter is D and length will be 3D, and which is subjected to compressive force. So F is compressive force here. At the top point, calculate the stress at the bottom, the support point. So we need to calculate this. So here it's an initial problem. It's not similar to the torsion, but it's similar to both stress and the torsion also. So there are a few options like 12F by pi d square and 16F by pi d square and minus 4F by pi d square and minus 12F by pi d square. Please take a look and try to give me the answer. I will give 2 to 3 minutes. Do you have any idea? Then you can share me. Okay. Do you have any idea regarding this? Anyone can respond. Anyone can respond. Is there any idea? Okay. So this is the explanation now how we can get the answer. So the answer will be of D minus 12F pi d square. So look at the problem. So we all know about the formula for M equal to Fd by 2. The force is applied here. Stress due to axial force sigma A is F by A, force by area, and we all know about for area pi by 4 into d square. So by solving this, 4F by pi d square. So since it's a compressive, okay. And due to bending, so sigma b equal to m by I, my by I, it is equal to Fd by 2 into d by 2 by pi by 64 into d power 4. So finally, we will get 16 F by pi d square, just tensor. So combined stress sigma r equal to A by sigma b. By solving this, finally, we will get sigma r equal to minus 12F by pi d square. This is what. So here, so we need to understand what is actually exactly given, what we're going to calculate. And the next one is, look at this problem. A maximum shear stress developed on the surface of solid circular shaft under pure torsion is 240 megapascal. The shaft is doubled when the maximum shear stress developed corresponding to the same torque will be. So what is the data is given here, and what is the value of torsion is given, and shaft diameter. If the shaft diameter is doubled, maximum shear stress developed corresponding to the same torque will be. You just try to understand this problem first, and you try to give me some idea to solve this problem. I need anyone to respond. No one? Okay. You first look at the problem. Maximum shear stress developed on the surface of a solid circular shaft under pressure, under pure torsion is 240 megapascal. This means tau is equal to 240 megapascal, which is given. If the shaft diameter is doubled, then the maximum shear stress developed corresponding to the same torque will be. The diameter will be if the diameter is increased or doubled, then what will be the shear stress? We need to calculate. Let us take tau 1 equal to 240 megapascal. When the shaft diameter is doubled, maximum shear stress will be T2. Let be the original diameter, tau 1 by tau 2 equal to Tr by Ip. Since the torque in both the cases is constant, we slightly change the equation, R by Ip into Ip by R2. So by applying the value for Ip and R as d by 2 into pi d square by 32. Similarly, that pi into 2 d power 4 by 32 into 2d by 2. By solving this, you will get pi d get cancelled, and d power 4 and here d power 4 into d, finally it would get cancelled. Finally 16 by 2 we will get 8. So T2, so tau 2 equal to tau 1 by 8. We know tau 1 equal to 240 megapascal. So by applying that, by solving 240 by 8, you will get 30 megapascal. So this is the actual value when maximum shear stress is 240 megapascal and the diameter is doubled. The maximum shear stress will be 30 megapascal. So it indicates that if the diameter is doubled, then the shear stress will be decreased. So it's a simple concept. Just try to take a look at it. Then we will move to the next problem. Okay, shall we move to the next problem? Look at this problem. A solid circular shaft of 60 mm diameter transmits a torque of 1600 Newton meter. The maximum shear stress developed is, so diameter of the shaft is given as 60 mm and torque which is given as 1600, the value of maximum torque developed. So we all know about the formula. So we know about the torque formula and tau formula also, maximum shear stress development formula also. So kindly recall the formula for torque as well as shear stress. Then we will look at the answer for this problem. So tau equal to, so we know that T equal to pi by 16 into tau d. Okay. So what we know is E and the torque. So we change the equation, tau equal to 16T by pi d cube. It's a simple equation. So replacing T as 1600 and D as 0.06. Tau equal to 37.72 megapascal. This is the equation. This is the actual answer what we have obtained. 1.72 megapascal. Going to the next problem. Look at the problem. Hello, sir. A stepped steel shaft is shown below is subjected to 10 Newton meter torque. The modulus of rigidity is 80 gigapascal. Strain energy in the shaft is Newton m. Okay, stepped steel shaft is below. Here the stepped steel shaft is given. It is subjected to the torque of 10 Newton meter. The modulus of rigidity is 80 gigapascal. The strain energy in the shaft is Newton m. So we need to calculate the strain energy. So the value will be the correct answer will be 1.73. So look at the picture first. So the stepped shaft, the first initially the diameter of the shaft is 50 and the length will be 100. And the next shaft is 25 mm and the diameter will be 100. The torque will be of 10 Newton meter. So what we're going to calculate is strain energy. So how do we calculate? Look at the picture. So initially, so we know the torque will be similar for all these shafts, which means throughout the shaft the torque will be similar. So T1 that is equal to T2 equal to T equal to 10 Newton meter. So now, first we need to calculate the polar moment of inertia, J equal to pi by 32 to d power 4. So pi by 32 into d is mentioned as 25, so 20 power 4 and of the length. So for G1, 80 gigapascal is given. Apply the value T1 equal to J1 G1 theta 1 by L1. So what we need is we just change the equation for theta 1 equal to T1 L1 by J1 G1. Theta 1 by theta 2 equal to torque is similar, so we might replace the T J2 by J1 L1 by L2 into G2 by G1. Whereas theta 1 equal to 4 theta 2. So theta 1 plus theta 2, 4 theta 2. Finally, we will get a value of 5 by 4 into 0.33 10 minus 3. So strain energy will be, the formula of strain energy equal to half T into theta. So T value is 10 and theta value 5 by 4 into 0.33 into 10 to the power of minus 3. So finally, we will get to 1.73. This is the value we have obtained for strain energy equation. Okay, so next I will show some another videos regarding this gate problems. If you have any doubts in this, you may ask me. Ready to explain you. Wait, I will show the other videos regarding gate problems. Wait, I will show this. I hope it is visible to everyone. Let us see the problem. Find the power transmitted by a circular shaft of 50 mm diameter at 120 rpm. The maximum shear stress in the shaft is not exceed to 60 Newton meter per mm square. Okay, just to take a look at it, look at the question, and also try to observe and try to note the data as whatever is given. For solving the gate problems, we need to understand the data first. Okay. Okay. So look at the question. So find the power transmitted by a circular shaft of 50 mm diameter at 120 rpm. The maximum shear stress in the shaft is not exceed to 60 Newton per mm square. So the diameter of the circular shaft is 50 mm and the speed is n equal to 120 rpm and the maximum shear stress in the shaft is not exceed. So tau equal to 60 Newton per mm square. So what we're going to calculate is power transmitted. So we all know about the formula for calculating the power P equal to 2 pi nt by 60. So here P is not given, we need to calculate. So T is given, N is given and 60. So 60 is 2 pi nt by 60. So N and T is given. So with the help of that we're going to calculate the power. Sorry, here the tau is given, not T is provided. So we need to calculate the T also. Yes. So, so we know the formula P equal to 2 pi nt by 60. The unit is watts. And for T, torque T, we need to calculate the torque. So how do we calculate? T equal to torque transmitted by the shaft. T equal to pi by 16 into tau into d cube. So here tau is given, d is given. So we try to apply the values here. T equal to pi by 16 into tau as 60 and the d cube for d as 50. Solving this, you will get So the help of that, once we are applying a value, we will get the t value. So if we get the t value, then we substitute the t value in the power to get here to get the power. Can anyone solve the problem and tell me the answer? Is there anyone? So no response. Okay. Okay. So since we have another torque equation, another torsion equation, right? Another torsion equation. T by j equal to tau by r equal to g theta by L. So that of that equation also we can able to calculate the uh, twisting moment. Okay. So the help of that T by j, we know that pi by 32 to d power 4 and tau is given, r is d by 2. Therefore, this also we might use this to get the t value. So whichever is possible, whichever is easier to calculate, so you try to calculate the equation. Okay. So if you're using this term, t by j equal tau by r, see here that this is a circular shaft, diameter d, and r is the radius, so d by 2. Replacing here as d by 2. So we already know that j, so t, we hold this t here on the left hand side and move the j to the right hand side, j by r into t. So j equal to pi by 34 into j equal to pi by d power 4 by 32 into tau by d by 2. Whereas d power 4 and d get cancelled. So here d cube will be available and 32 and 2 get cancelled. So 16. So pi d cube by 16 into tau. So torque t equal to pi by 16 into tau into d cube. Whereas we know that tau value is given and d value is also given. So with the help of that, once we are applying the value, see here, the permissible shear stress value, we apply the permissible shear stress as 60 and the D value as 50. You will get, solving this, you will get D equal to 1472621.556 Newton mm. We need, whenever we are applying a unit for twisting moment of torque, it should be in Newton meter. So we try to reduce this term. So by divided by 1000, you will get a T equal to 1472.621 Newton meter. Now, with the help of this T, we're going to calculate the power value 2 pi nt by 60. So by substituting this value here, 2 into pi into n as n value is given, and substitute the T value here. By solving this, you will get n is 120 and the T is 1472.621 by 60. By solving this, you will get 18505.50 watts. So which means divided by 1000, you will get 18.50 kilowatt. 18.50 kilowatt. Okay, so this is what they have asked. They have asked the power transmission. So 18.50 kilowatt is transmitted using this shaft. Any doubts regarding this? You may ask. Any doubts? So since we have only 15 minutes, so I will try to give you another video. See another problem, another gate problem. So to solve the other gate problem. So look at this. So this is a gate 2016 problem. Gate 2016 problem. So what they have mentioned is, so this picture will depict the shaft is fixed in a wall. Here when it is fixed on another end, we are going to apply a load. So we need to calculate the vertical deflection at point A. That's the major thing that they have asked. So this is the A. So we need to calculate the point of deflection at point A. Here we're going to find what is the vertical deflection at point A. In this case, the shaft is fixed. The shaft is fixed at one end and free at the another end. End of the shaft, we are fixed here. A rod which is fixed here, perpendicular to the longitudinal axis of the shaft. So the length of the shaft from point this is L and there also L, so it is 2L. And also the two equivalent opposite forces will be acted here, which is otherwise called as couple. So the torque applied here is P into 2 times of L. So applied a torque here. Since we are the length, the L and L on the other side, so P into 2L. So in order to find the angle of twist, so since we are applying a couple, the twist will be happening. So we need to find the angle of twist. So in order to find the angle of twist, T by J equal to G theta by L. We all know about this formula, and also tau by R. So this is the formula to calculate the torsion equation. So you need to find the theta. You know this J value on torque and tau value. So with the help of this, you can calculate. So T have another specific expression and J also has a specific expression. With the help of this, we're going to calculate the theta value. So T L by G by J into J. Whereas we know that T equal to P into 2L into L by J into J. So G already we know that pi by 32 into D power 4. So here replacing D as 2 power 4 and 32 will be moved to the upper side. So theta equal to by solving this PL square into 32 pi G into pi into 2 power 4. It's a 16 R power 4. R power 4. Okay, so by cancelling this, you will get 2, 16 and 32 you will get 2. So finally 4 PL square by G pi R power 4. So this is the theta value. Okay, and next what happens here is the end of the shaft, this is going to be less than this. It's going to take this as the end of the shaft. So here the twist will happen by like this. This is the point where the twist will happens like this. So this is theta. Here the rod is like this. It will be deviates or deformates from its original position. This is a deformation happens due to this twist. This deflection. This is called vertical deflection. That we're going to find. This is theta. Okay. So we need to find this distance. So we need to use the formula called tan theta equal to this distance. So going to find is h divided by the length. What is the length here? L. Okay. So for the half of the side, it will be L. So h equal to L into tan theta. Tan theta is equal to theta. So h equal to theta into L or L theta. Let me take this the value of h, it becomes L into theta or theta into L. So we know the value for theta as 4 L square G pi R power 4 into L. H equal to 4 L cube by G by R power 4. So this is the value for H. This is what they have asked the vertical deflection at the point A. Okay. So okay, I can stop here. Do you have any queries? You may ask now. Still we have 10 minutes to go. Any queries? You might ask me. I will try to explain you. So I'll stop here. Do you have any queries? You may ask now. So this is one of the important topic in strength of material torsion. So since we have discussed torsion of springs, and what is the difference between solid shaft and hollow shaft, what is the importance of solid shaft and hollow shaft, how do we solve the gate problems. So for gate problems, you might understand the first thing you need to understand is you need to get the data from the question. So how and how to solve. For that, you need to get the data first. So you try to understand the questions. If you are not understanding the concept or understanding the concept of these questions, then it is difficult for you to solve the gate problem, since the gate problems are not literally taken from any of the books. The gate problems are solved application problems. So based on the IITs, so different IITs are setting the question paper, gate question papers for each and every year, different IITs. So we might understand the concepts first initially. So for that, the expression, the formula for every context is very important. So you try to understand so what they are trying to tell, what they are giving, everything problem along with the solution. Otherwise, it is difficult to solve the problems. Okay. So do you have any queries? You may ask now. Still, we have another 7 more minutes. So if you want to crack the gate exam, so you need to practice more and more with the different problems. So IITs provide different source links with gate solved patterns. So in that manner, you will go through that. You will work out the problems. You will get more. You gain more knowledge on each and every concepts. Then it is easy for you to regular practice. It is easy for you to solve the complicated problems. Otherwise, it is quite difficult to understand the concepts of gate forums and the gate problems. Okay. Okay, the session is open now. It's up. So 7 more minutes. Do you have any queries? You may ask. Okay, so there is no more queries, right? So thank you for your patience to observe this session. And I hope it will be very useful for you to understand the basic concepts of torsion. and the problems will help you to learn the torsion problems in GATE exams. All the best, guys. Thank you so much. So I will close this session. Thank you so much.